Hello everyone. My topic today is analysis of bandwidth or location approaches in the wireless ad hoc network. First, I'd like to introduce the abstract of my presentation. It includes two parts. The first, this paper compares different bandwidth location approaches in wireless ad hoc network. And second, I also proposed a new approach for a bandwidth allocation in ad hoc network. And here is the outline of my presentation. Let's first go to the introduction part. What is the ad hoc network? An ad hoc network is one kind of wireless network which is decentralized. It collects different wireless users to form a network. And this network is not based on an existing network infrastructure, and the structure of the network is decided by the users join the network, so it is dynamic. Based on this property, the bandwidth allocation is a key problem in ad hoc network. There are two constraints in bandwidth allocation. The first is the bandwidth capacity constraint. The second is the MAC constraint. I will not go in detail in the MAC constraint, and my paper is only concerned the bandwidth capacity constraint. So I propose new method for bandwidth allocation, and I will go in detail later. And I also simulate this approach using Java language. First, let us say several existing bandwidth allocation approaches. All these approaches are based on fairness or efficiency or both of them. For fairness, three fairness should be introduced first. Maximum fairness. A division of the bandwidth resources is said to be maximum fair, when firstly a minimum data rate that a data flow achieves is maximized, and second, the second lowest data rate that a data flow achieves is maximized, and so on. And this mechanism first satisfies the users which has small need for bandwidth. And a proportional fairness tries to maximize the total wireless network throughput, while at the same time allowing all users at least a minimal level of service. And this is done by assigning each data flow a data rate for a scheduling priority that is inversely proportionally to its anticipated resource consumption. And also, the weighted fairness is the extension of all other fairness standard. And the idea is to give each data flow a corresponding weight which is in proportion to its bandwidth. So this mechanism can let users decide their own priority to achieve some kind of bandwidth service level. And several papers are written based on fairness. And also, however, the efficiency standards is not compatible with the fairness. And if some the price-based approach is provided by a paper, but it lost the fairness in order to achieve the efficiency. So under the condition of the fairness, trying to find the optimal solution to maximize the utility function is more important than guarantee efficiency at the sacrifice of fairness. So several papers rate the compromise between fairness and efficiency throughout choosing utility functions. Unlike the maximum utility and alpha fairness, alpha beta fairness. In my paper, I mainly provided new approaches for bandwidth allocation in ad hoc network. Because the bandwidth are scarce in the ad hoc network, if there are lots of users in it, then for this situation, I introduce a priority for each user. In fact, each user has its operation time, and each of them is different. Based on this property and the multi-threading idea, think of the bandwidth allocation can be implemented by like a multi-threading. Each user will use its maximum bandwidth in the ad hoc network and perform operation for some time. And at one time, only one user can operate, but it cannot execute for a long time. Then after a defined time, another user can operate and use this channel. And I use the Java language to do simulation in my project, and I also use the semaphore in my programming. The semaphore is, I think all of you can know Java language, and some of you may not familiar with the semaphore. A semaphore is a variable of abstract data type that provides a simple but useful abstraction for controlling access by multiple processes to a common resource in a parallel programming environment. We can think of a semaphore as a record of how many units of bandwidth resource are available, coupled with the operation to safely adjust that record as units are required or become free. And if necessary, wait until a unit of resources become available. Semaphores which allow arbitrary resource count are called counting semaphores, while semaphores which are restricted to a value 0 and 1, locked or unlocked, are called binary semaphores. And this is the implementation of my new purchase. You may assume that there are 8 users in the network, and the bandwidth is not sufficient. And the competitive mechanism is implemented by binary tree in my project. Consider a binary tree with n leaves, one for and one for each user, and the power of 2. Each internal node of the tree has the associated semaphores, and here we can see the 7 circles means the semaphores. And the users designed to operate, the operation such as the send or receive packet from other nodes. And this user should get the m semaphores from the first non-leaf to the root of the tree to get the bandwidth. Here the m is 3, so the user should get the 3 semaphores to get the semaphores. How to compute for this semaphores is key problem I should solve in my project. The input of my program is the network properties. The P1 to P8 stand for the 8 users, and N means the number of users, and M means the number of semaphores needed to get the bandwidth. So each node begins with some sleep time and tries to acquire the semaphores. It is successfully enriching and obtaining the root semaphore to get the bandwidth and execute with the simulated operation time. The user then releases the semaphore so that the others can acquire it. That is how this mechanism works. If the network properties changes, the result will be different. So that is the input of my program. So I will show the results in static network and dynamic network. This is the programmed result of my state network, which is no new user will join the network. The output uses, and here we can see this result means that this is only shows the all the nodes get the first time when all the nodes get the bandwidth. The program the program ended when each node get the bandwidth 3 times. So I will not show here, but the result is same with the first time in the last two times. And this result means that at time 200, the user 7 got the bandwidth list and can perform operation for 500 milliseconds, and then it released the semaphore. And consequently, the user 1 got the bandwidth, and the sender received data packet for 200 milliseconds. And the other users will act like this until all the nodes in the network get the chance to operate. So under this network configuration, the bandwidth allocation order would be 71538264, as we can see here. And when the 4 users leave the bandwidth, there are only 4 users stay in the network. So the bandwidth method will be changed because the network configuration is changed. In this situation, the answer is shown like this, and the bandwidth allocation order is 2314, and then it will repeat this order in bandwidth allocation. And I will make in conclusion in this part. In my paper, I analyzed the several existing approaches for bandwidth allocation in ad hoc network and demonstrate a new bandwidth allocation method. In my approach, I assume that all bandwidth can only be used for one user at each transmission. And this idea is inspired by multi-threading in computer science. Then I used the Java language to implement this approach and show how users compete for the bandwidth. That is, which user the network should assign the bandwidth at a certain time. And I also consider different situations in the ad hoc network because the old user might leave the network and the new user might join the network. So the network configuration will change time to time. In my approach, I generate 2 results. One is 8 users and another is 4 users. And the conclusion will be different when the network configuration changes. However, there are a lot of however, this approach is only a basic idea for bandwidth allocation in ad hoc network. It considers only one system should allocate the bandwidth to which user, but not consider how to allocate the bandwidth. The bandwidth allocation in the ad hoc network needs a lot of techniques. In the future network, I should consider all these affecting factors. On the other hand, the mode I demonstrated is only the simplest one. In fact, the system can allow the maximum number of users in the network based on its capacity. For example, the network can allow 8 users at the same time. However, there are 12 users at this time, so the other 4 users should compete for the ticket to get the bandwidth. So in the future, I will generate a model to simulate this situation. This model will improve bandwidth efficiency and more useful than the model in this paper. In this proved approaches, I should consider the MAC constraint because the several flows might share the nodes. Okay, that's all. Thank you. Now I will show how to run my program. First, you should open the workspace with Java Eclipse, and the second, run the bandwidth allocation.java. This is the resource code. And here is the running process of my program. And after the 3 times the user get the bandwidth, the program will be ended. And here we can see at the time 200, the user 7 get the bandwidth, and at time 700, the user 1 get the bandwidth. That's all my output. Thank you.